Hey, Miss Brett here to help you figure out some things with this rule that we learned on Friday. This is called, once again, the empirical rule. And remember that in order to use this rule, data has to be normally distributed, all right? And so basically, if we have our mean here, in the middle of our distribution curve, this empirical rule tells us that 68% of the data will lie within one standard deviation of the mean, 95% will lie within two standard deviations of the mean, and 99.7% will lie within three standard deviations of the mean. So I know that this diagram has some additional decimals, but let's just agree to use 68% within one standard deviation of the mean, 95% within two standard deviations of the mean, and 99.7% within three standard deviations of the mean. Okay, all right, so now that we have this rule, how do we use it? Well, we can answer some pretty basic questions regarding what to expect in a normal curve, and we can also answer some questions that get a little bit more complicated. So you have this note sheet that I want you to complete before you start the assignment. So I made an example here for you. It says the population of NBA players is normally distributed with a mean of 6'7" and standard deviation of 3.9 inches. So that would be the height of NBA players. Draw and label a normal curve for this distribution. Well, the first thing I would recommend doing is converting the 6'7" into just inches, since standard deviation is in inches. And so to do that, we're going to multiply the 6 by 12, that's 72, and then add on the 7 inches, so we get 79 inches altogether. So for this example, our mean is equal to 79, and standard deviation is equal to 3.9. Okay, so if we're going to draw and label a normal curve, well, I already drew it, but the mean always goes here in the middle. And so our mean is 79. And then we add 3.9 to get these three. So 79 plus 3.9 is 82.9. Add 3.9 again, 86.8. And then add 3.9 one more time, 90.7. Okay, and then going in the other direction, 79 minus 3.9 is 75.1. And then minus 3.9 again, 71.2. And minus 3.9 one more time, 67.3. Okay, so we know those values represent whole number standard deviations away from the mean. So this is at +1, and this is at -1 standard deviation. Okay, so within one standard deviation of the mean is from 75.1 to 82.9. And then the 86.8, that's +2 standard deviations. 71.2, that's -2 standard deviations. All right, so from 71.2 to 86.8, those are values within two standard deviations of the mean. And then 67.3 to 90.7 within three standard deviations of the mean. So this is -3 standard deviations, and this is +3 standard deviations. Okay, so we can answer a couple questions here. So first of all, what percentage of NBA players would you expect to be between 75.1 and 82.9 inches tall? And so from 75.1 to 82.9, that is one standard deviation on both sides. So that would be 68%. Because 68% of normally distributed data falls within one standard deviation of the mean. The next one, between 71.2 and 86.8. 71.2 to 86.8 is here. Okay, that whole space is within two standard deviations of the mean. And so that's 95% of the data. And then finally, between 67.3 and 90.7. That's from -3 standard deviations all the way up to +3 standard deviations. And so that is 99.7%. Okay, so those are just really basic. That's how you use the empirical rule. The rest of the questions are a tiny bit more complicated. So for this first one, what percentage of NBA players would you expect to be more than 79 inches tall? Well, 79 is the mean. And as long as the interval you're looking at is symmetric, you can divide it by 2. So the entire curve has an area of 1 or 100%. So the mean cuts that right in half. So more than 79 inches tall would be half of 100%. 100 divided by 2 is 50. So we would expect 50% of them to be taller than 79 inches. What about taller than 82.9 inches? Well, if I know that, I'm going to draw just another little curve here. Okay, so there's my mean. 82.9 is at +1 standard deviation. So I'm looking at what percent lies from there to the end. Okay, so if it was from here to the end, it's 50%, but I'm missing this space in the middle. But between -1 and +1 standard deviation is 68%. And this is a symmetric interval. It's the same on both sides. Then each part of it is 68 divided by 2, or 34%. So the shaded region right here is the top 50% minus this piece, which is 34. So I can figure it out by 50 minus 34, which is 16%. And then finally, between 75.1 and 86.8. So 75.1 is -1 standard deviation. 86.8 is +2 standard deviations. So I have to figure out the total between there. So here's our mean. Here's the curve. Here's the halfway. I need to go from -1 standard deviation, which we just said was 68 divided by 2, half of 68, to +2 standard deviations. Okay? Well, 95% of the data lies within 2 standard deviations. So this piece here is half of 95, or 95 divided by 2. Okay? So I have to add those two together. So 68 divided by 2 is 34. And 95 divided by 2 is 47.5. When you add those together, you get 81.5, 81.5%. All right. So these are your notes for today. There's a packet with problems in it. Miss Johnson will let you know which problems you need to do. But there's a lot of problems in there that I think some of you will enjoy trying to figure out those percentages. Anyways, good luck, and I will see you tomorrow.